I have 3 glasses of water, Hannes.
You're ready to rock.
Yep.
I've never seen you this ready to go. And with that, I say welcome to YouTube as well. We're live on all our platforms, Martin. Welcome, everyone, and welcome to you, Martin. How are you doing?
Thank you. I'm fantastic because I've sneak peeked on that we have a lot of sweet suggestions. So what we're doing today is a collaboration with Onshape. When I moved to the studio, Ludwig was an Onshape user, and Ludwig said, if you want to collaborate with the audience, you should switch to Onshape. And so Onshape is sponsoring this stream, but the truth is that I absolutely love working on Onshape because it's the Google Doc of CAD software. And we're going to demonstrate that in this stream. So if we go over to the computer here, I have asked for design suggestions from my viewers on how to make programming pins that I can snap in and out myself. So last week, Axel sent a great suggestion that Axel later updated and removed hardware and made a snap-in pin that I remixed into a really bad design here, but it was the starting point for the kind of design help I asked from the viewers. And we have here, ready to go, 11 Onshape links from fantastic people. Yeah, I'm really excited to go.
I just want to say before you head into it, I saw from Twitch here now, Axel.
Oh, nice.
That's me! Axel is watching on Twitch.
Axel started all this, and Axel should have a lot of. Ooh, it looks like Axel has. Okay, Axel is actually a new design suggestion number 11 here on the list. So we saved the best for last with Axel.
Perfect.
So without further ado, I want to demonstrate to you how fantastically simple it is to work together on CAD. Did you want to say something before I go into it, Hannes?
Yes, it would be so nice to just have a little recap of what we're doing. I know it's part of the big programming wheel that we see behind you over there.
Yep.
Right? So this is the programming pins that goes on top of the programming wheel, just so everyone knows what we're doing.
Thank you, Hannes. Very good. I've been thinking about this, so I lost track of the big context. So the Marvel machine should tour live, and the music is going to be played by cam discs, these kind of profiles on a cylindrical programming wheel. And what I have asked in this design that we're looking at right now, I have stainless steel programming profile. This is just a concept. That is like watercut or laser cut. And
do you keep forgetting which camera you're in?
Yeah, I am in this one now. I know. I know now. And then we have this curved base, really thin 1 millimeter sheet of metal. The idea for these plates was that when the music is set in stone, we make them. We kind of twist the tabs on the backside, and these plates never change. They're like solid steel and very heavy and stuff like that. But then when I asked for input on this, a lot of people went the 3D printed route. And I was like, 3D print, is that really good enough? But the cool thing with the 3D prints is that not only will I be able to program music on the machine, not fast, not during the concert. During the concert, we will have pre-programmed plates to just switch the songs really fast. But in the studio, and I can also print whatever profile I want because I have the printer in the studio. So it's a very interesting thing. And I think perhaps we're going to go with both design routes, that we're making stainless steel versions of the really finished songs, perhaps, or we realize that the 3D printed solution is good enough or really good. Also cool on the world tour. If something is missing, we can print a new profile. Or if I felt, the snare drum fill should be daga daga and not dat daga, like I add a new profile the
daga daga.
Like so yeah. And also,
it is a distinction between profiles and pins. I already see in chat we are so used to the word programming pins. Now we're talking about profiles.
Always the profiles for reasons that we've been discussing for a long time. And the major design difference now is that both on my suggestion and on Axel's beginning suggestions, we needed to access the backside. And what I asked for with this design is pins that could be profiles, that could be, when I say pins, I mean profiles.
Yeah. Me as well.
Yeah. So we want to be able to insert these programming profiles from the surface of the wheel, because the wheel is gigantic in its current form. So you can't like access in here. So that was one of the design requirements that I asked everyone to do. So now I actually want to look what people have made here. So here's how it is. Someone sends you a link. I click it, and it's opening in Onshape. Onshape is browser-based. And
what? Is it already in the software now?
Yeah. So that's
You didn't need to download the file?
No. The only thing I need to do is update my dark reader to not have this on the inverted list.
Okay, there we go.
And I already see an idea here that I love on this design. So let me just check who this design was from. It's from Joachim Sack. I'm gonna take this name and save. So the next thing you do then here is, so this is view only. Where do I make a copy? Oh, I already copied this. Okay, now I realize. This is one of the designs that I sneaked peek at. And now Onshape is not giving me the option to make a copy because I already copied this to my own library, I realize now. Mm-hmm. So then I can make a copy and start working with it. So I need to go and look for the copy that I already prepared pre-stream. So let's go.
The cooking show.
Yeah. A cooking show.
I will go here so we don't sneak peek on your screen. And here we can take a look at that wonderful programming wheel that is being firmly discussed today. These profiles that we keep talking about, the programming profiles, they're going to be on the outside of that little small programming wheel. That's the mock-up that you see there in the back to the right there. Quite spectacular, quite large. And you know what? While Martin is finding this Onshape stuff, let me just press this button here and share with you guys that you can try Onshape free using the link that you see on screen here. And it's also in the description. It's onshape.pro/Wintergatan. And you can get up to 6 months pro. So if you are hesitating to trying Onshape, don't use the link. As you can see, it's quite awesome software. Okay, enough plugging from me.
Nice. So perhaps we kind of learn that this designer hasn't allowed me to make a copy, I don't think. So I'm learning now. So if I double click on the next design, we'll see if I have that option here. Yeah, so here is make a copy to edit. So I think that is when you share the link, you can add the little thing, the tick box to allow me to make my own copy. So in this case, 9265. Let's see what the name of that designer is. It's Julian. So I can then make a copy, and then I just add that Julian prog pin. And I choose to put in my own folders, and I copy here. And this is the magical moment, is that Julian's design is then under my complete control.
Oh, wow.
So,
it's in your hands now.
So already now, there's a lot of tabs in here. I didn't see that before. Interesting. Oh, Julian has made, interesting. So now I can look at everything Julian has made, and I can edit it. It's effortless too, and I can go through all the trees and everything. So Julian,
all this from just a link.
Yes,
pretty awesome.
So Julian hasn't made one profile. Julian has made 4 suggestions. I realize now.
Oh wow! Busy bee.
Yeah. So this looks really interesting. Oh wow, with drawings, fantastic, Julian.
Wow.
And I'm going to go back on the first pin soon. Low friction material, band, universal snap press. We're going to go through this, and then there's an assembly. Okay, so what I think Julian has... Ooh, this is interesting because Julian has solved the printing direction. So I think these are printed separately, and these are printed separately. I guess that's what Julian means with this color. So let's start. I actually want to start. I'm very linear, so we're going to get back to Julian's design here. I want to start from the top of the list. With the thing that I couldn't make my copy of from Joachim Sack.
Yep.
So you can add the Joachim Sack. Yeah, design concept by Joachim Sack.
Got it, brah.
And Joachim has made something that I absolutely love. It's it wasn't like that. That's interesting. That's different. But what Joachim has made, Joachim Sack here, is that the snap is only on the back side and the front is only a lock. And I think that's a really, really good idea for a snapping pin. So you can see here the holes here is you put it in and you slide it forward, and that's mechanically locked here without anything springing or anything. So during the stream today, I want to capture some concepts in text in my spreadsheet, which is here. Sorry for the white background here. I'm getting a hang of Dark Reader because I don't want Onshape to look strange. So here's the concept groups that I prepared. And I want to say that front snap solid, back snap springy. I think that is a really good concept that Joachim Sack has shown here. So otherwise, I think this is a really good design. All the holes are the same. We can see here. This is an interesting detail. I think this is kind of when you want to unlock it, you push something in there or something. Yeah, I think that's the idea, that you kind of have a tool here through the whole thing to push on this.
Ah, okay.
And also another interesting thing is that because we have a perpendicularity issue, and Joachim has just made the entire pin the same width. So I guess so that's really interesting. So thank you so much for sending this. I'm excited to go through, take a look at everything that we have received. So thanks, Joachim. We're gonna take a peek on the next suggestion here.
Fantastic. Suggestions in multiple, because Julian has been busy.
Yeah, so very much so. I think also one of the design guidelines was to think about print direction. So a cool concept with this pin is to make it, to not make it solid, to have actually air to have holes in the middle of the pin. I would never have thought of that idea. I want to write that idea down. What can you call it? Holes in profiles, material, and weight saving. Imagine we print 10,000 of these profiles. Of course, we don't want to remove that much material so it gets too weak, but it's a really cool idea that I would never have thought of myself, actually. And it's kind of beautiful, and you can grab it. You can grab it here. I'm going to read more in what Julian said, because it feels like this is one concept, and then the snap fit here works differently. I feel this is kind of thin. It's 1.4 millimeter material. So that's, I think, something that is important with all these designs is to make these snaps reliable over time. It depends on the material and everything. So I think that's really important, where I think that these snaps looks better. Perhaps Julian wanted to show the design evolution here. Maybe this is just the next version of... let's see if Julian made any...
iterations.
Yeah. There's no comments. There is a comment function. If you want to, you can choose a surface here. And wait, I think if I right-click... When you collaborate in Onshape, you can right-click, add a comment, and say this is iteration 2 of the same concept, and I can add it to that page here. But the thing is that unless you press comment, you won't see the little comment emoji there, icon. So here I think the snaps are really secure. We have a timing thing in the middle there. Cool. And then I think the multi-layered... Oh, this is kind of cool because this is also with printability in mind, I guess. So this is basically same idea as this, but simplified. Beautiful. I don't know if these are 2 channels. They could go together as 1 pin. And then number 4, which is 3 prints for 1 pin. Then I guess this is kind of the feet. Let's see what Julian is writing here.
I got a comment from Derek Van Allen here that says comments also don't show up in the copies of documents. They would be in the original's pre-copy.
Oh, interesting.
Just so everyone knows.
Great, Derek.
And then I think PCH video 1, but this might be Julian. All my comments are in the drawings.
Oh, nice to have you here, PCH1. PCH video 01.
Could be Julian, right?
Yeah, or it's one of the other designers.
Yeah.
So let us know if which design is yours. We would love to have a voice channel set up in the future. We haven't been able to fix. We don't know how to do that yet.
One step at a time.
Then we could have. What I really like with this is really interesting to make them in several parts. One part is of course less than 3 parts, but here you could. It's an interesting idea to actually separate the functionality. So the low friction is this. Let's see what Julian writes. 3-piece universal snap-in press fit system designed to lock cleanly into a slot or gap in a metal sheet. Central peg body is intentionally made slightly narrower than the full opening. The tight fit is achieved by the 2 outer plastic pieces which flex inward during installation and then press outward against the edges of the slot once seated. This creates a secure, self-centering press fit without needing screws, adhesives, or permanently rigid, oversized part. Key advantage is that the central layer can be made from low friction or sound dampening material, allowing the assembly to reduce rubbing, vibration, and noise while still maintaining a precise mechanical fit. Love that concept, actually. So I'm going to write it down.
And we got a yes on... It is Julian that was chatting with us.
Cool.
Good to have you here.
Multi-part, different materials, different parts, does different jobs. It could be... It's a really good concept. That I also probably wouldn't have thought of myself.
Just giving you a reminder here, Martin, as well. If you want to show something closer, you got the zoom button today.
Oh, nice.
Just so you remember.
Yes, that's a really good idea. Okay, so that was from number 4, and now is from... This version is more print-friendly. Okay, so now we're back to the comments on this version. Now I see your structure, Julian. Thank you for thinking through so thoroughly. This is quality. Okay, now I want to show everything. This is the first time of me being inside Onshape drawings as well, so that's fantastic. This version is more print-friendly. 2 separate prints that snap fit together cleanly. Instead of using different clip types, it relies on one universal clip system repeated along the profile. The tension is... Yeah, for plywood parts, I did this trick a lot on the Machine X. When I wanted things that 2.5D CNC machining couldn't do, I always did this. I mirrored to get like 3D printed geometry. And I think most people who are watching this are familiar with printing direction. You would print this part lying down like this, and you would not need any support anywhere. So that is yet another great idea from Julian to a concept. So multi-part eases print direction, no supports. Cool. And then the explanation for this one. Release clip system. This was a really elegant one. The profile can be pressed by the thumb. Main drawback is printability, awkward orientation or supports. Good evaluation could be modular design where the main profile prints cleanly and the clip section snaps or slides into it separately. I was thinking of that basically on this one, these clips you would want to print on this side and perhaps add them. So the clips can be printed separately. So that's another really good design thing to remember. Multi-part allows multiple print direction. It would be nice with only one, but Julian has gone far into the advantages of multi-part. And then for the last explanation of the first one, so fantastic that people are thinking so much. I'm getting so much inspiration from seeing this.
Talented bunch out there.
Yep. Bottom follow drum radius, that's good. Yeah, split down the middle and then print if FDM. Fantastic work, Julian. I think these are 4 super strong starting concepts. Awesome. I think I'm going to return to everything, but I'm excited to keep looking here. But
yeah, of course.
Huge thanks to Julian for doing 4 designs actually, with a lot of good design philosophy in there. Let's go to Syminoma. I want to go through all a little bit quick and then go back and start to remix on top of these.
Yep.
And then I can also start writing some design requirements and go deeper into it. So here with Syminoma, we also have an option to make a copy. So I'm going to put Syminoma profile. I'll save it to my Onshape, and and it's all of a sudden my own. It's not my own, but
Dark reader, yes.
Dark reader.
Fantastic.
This looks very, very simple from this side. Let's see. Oh, okay. I have an idea around this. I was looking forward to see if someone did this. Oh, and this is really original. Do you know how this is going to be printed? It's going to be printed standing like this.
Yeah, standing, of course.
I think so, yes. So this is really creative. That would mean that this flex of this flexing clip here has the 3D printed printing lines in the correct direction. Because you don't want to flex along the layers, you want to flex against the layers. So that was really creative. Perhaps if we want to make like really high, it's a little bit like bad depending on your printer. That's also why these 45 degrees are here, because then the print can build them up. So this is printed in one part in one go, which is really elegant.
Yeah, simple and elegant.
Very simple. And then, so this is also designed with printability in mind completely. So then if we hide this part, we can see that the holes are really simple, and that you kind of first insert the front thing, and then snap on the back.
Oh, okay.
Which is exactly what the first design was. Front snap solid, back snap springy. But here's my remix on Suminomas and Jackum Sax. So that's the Martin stabilizing pressure idea. I want to show it. I'm gonna use Suminona's design here and show what I mean. So front snap solid springy-ish with pressure.
The professional language here. Springy-ish.
Springy-ish. What I'm worried about most with these is that they will flex sideways. So that they will not stay perpendicular. And I think to make them not be loose, we need to make these profiles hug the metal really, really hard, really, really tight. And as you can see here, there's a little bit of distance between the underside of the plate and this thing sticking out. I want to make that distance go away. So now it's just so cool. I get a link and I can just build on top of this. So I'm not going to go beautifully into the tree here. I'm just going to do bad sketching here now.
Oh, hide your kids.
Yes.
Martin is cadding.
Yes. Imagine here now if, let's see where can I show the origin? So we have the surface of the underside of the sheet is there. I can make that a construction line. So imagine if we make this thing a little bit thinner so it can flex. Perhaps I should actually make it a little bit beautiful as well. We have time.
Oh, we have time.
This is amazingly fun for me, Hannes. I can like remix on top of what people are sending.
Yeah. Seems like a extremely suitable way of collaborating for you.
That I don't need to talk to anyone.
Yes, yes. And the ease of access that you don't need to go into a certain folder somewhere, download a file or anything. People can just send a link that you open and the link just takes you to Onshape and you don't have to talk to people. They can leave their comments. Or as Julian did, the drawings. It seems tailor-made for you, kind of, this whole software.
I think later when we're getting into, I do want to talk to people I'm collaborating with, but it is true that like chatting on Discord and stuff takes a lot of time. And this is like, when I open this link, I understand exactly the intention. Mm-hmm. So there's no like, there's no misunderstanding, nothing.
There's no back and forth.
There's no back and forth. I love it. Okay, I'm doing this really badly. But it's my idea here. Look, we're pushing this above the surface here. So what would happen then is that we are going to do an extrude and remove. Yes, and we are going to do... I should have used Suminona's tree.
So speaking about Suminona... Wait, that's my design.
Oh, great.
Yeah, also joined by Suminona.
Fantastic.
So cool.
I love that. I love your design, Suminona. Thank you so much for sending it. I'm doing a bad remix of it right now, but you're going to see your design gave me this idea. Why is that not working? This way, and then I have to change face then. This way, yes, okay. So now what I've done, if we hide that ugly layer and if I make an ugly fillet here. So I want this to be a little bit springy then, that's why I make it so thin. And this is above the surface. So see what happens when we insert this and press this thing down is that this whole spring will push the entire pin into the metal. We're hugging the metal super tightly. so it wouldn't stick up, you know, Hannes. It would.
Yeah, I was wondering about that.
No,
doesn't seem right.
there's no hole here in the sheet. So in my, I can make I can make we can cut it off and I can rotate it so we can see that. I'm rusty with CAD. Let's see if I can just split it.
We're rusty, period. We haven't been live streaming for a while. So fun to be here.
Split. I want to split this one. I want to split it with you. Okay. Are you a separate part? Yes. It's super fun. I want to rotate you around this. Oh, the axis is in there. Okay. Let's rotate you around this axis then. That's not exactly what I wanted to do. And we're rotating you. So, oh, I split there as well. Yeah, I'm super rusty. Okay. Oh, that's embarrassing. Onshape, don't look.
Look away.
Don't look.
Don't hand him the keys to the castle.
No. Okay, when it's, I just removed that part. You see, when it's under, it's going to be depressed and not in the bad way. It's going to press down like that. Okay, everyone knows what I mean.
Yep.
Perhaps I should cut it better. But this added pressure, so you just push it in and then you click it down on the backside here, will add a lot of rigidity in the joint between the pin and the surface and will keep the perpendicularity. So that I think is a super bad execution of a very great concept. So
by you.
Sorry?
By you, we must add.
Exactly. So,
but we have some Unona here now that says, I designed this to be printed upright. I think I changed the bottom surface color, question mark.
I think you joined too late. I saw it immediately.
So if you add that in, it would be nicer to keep it within the 45-degree overhang.
Yeah. I saw, Simonona, I was really impressed by the creativity of your printing direction because I would never have thought about that. The bad thing, going back to Julian's suggestion, is that we would have layer lines on top of the profile in this printing direction where the readers want to read it. So, but still, I think it's a really cool idea. So if it's going to be printed like this, my little elephant tusk here needs to have maximum 45 degrees angle, which is no problem. But I really I was surprised. That's so fun to be surprised. And I'm
gonna surprise everyone with this camera angle right now because look at that. You can see Martin sitting in front of the computer and you can see the mock-up in the background.
Cheers.
Look at that. Cheers, Martin. Fantastic.
Let me go. I want to go a little bit fast and take a sneak peek on everything. And
okay. I'm not slowing you down.
No, it's me. That's me. If there is anyone who wants to send more stuff, the link to the Google form is in the description. I'll check it right under the stream. So here's another design.
It's from Sam, right?
And this I haven't sneak peeked. Okay, so this is a cool idea. It is printed on this side, and it has the perpendicular only on one side. And that's... Are there Wintergatan snaps? So the lock is here. How does that work? Is this the lock? So this has the spring on both sides. Here's the lock in the front. And I think one of the interesting concepts here is that you can actually print this on the side. The springs would have the print direction correctly. And there's no support, nothing, but you only get perpendicular support in one direction. But I think that's a really interesting concept that I want to write down. Sorry for burning your eyes here, everyone.
You're in the wrong document.
I'm trying... Perhaps we just have to accept that Onshape is going to be black. So perp supports. It's perp supports perpendicular on one side only for ease of sideways printing. No supports. I think that's a really interesting idea with this one. I'm gonna flick through all of them at all times. So I think in this concept it doesn't have the sturdy. It has snaps in both front and back, and I'm leaning towards only have this hook in the front, no snap really in the front. Kind of a snap. But thank you so much, Sam, for... There's also an assembly. Oh, no, there's nothing in the assembly. Thank you so much, Sam, for sending this. Absolutely love seeing this. Let's go to the next one. I have no clue what's going to come up here now. It can be exactly whatever.
Yeah.
Where did your mind go, Hannes?
Nowhere.
No.
What do you think? I'm thinking about different kind of profiles. Look at that. There we go. What do we
have here? We have, I want to save this. This is Fabricatis. That's a fantastic username. And 2 colors, which is interesting. Huh. Are there drawings? I'm going to make a copy to add it. Fabricatis profile. It's really nice when you add this ability to be able to make a copy, because then you can go in and look at it more.
Remix.
A remix is fun. It's really fun. I wonder if Fabricatis means that the 2 colors are two... Or is this the... So it's a hook. Yes, I don't really understand the 2 colors. And I don't know really what that one does, because we don't have the curved parts. So if you're in chat, Fabricatis, please let me know. Oh, wait, it slips in, right? It's probably slipping in. I think you slide the whole thing in. Which makes me think that perhaps my idea... Okay, so I'm getting an idea here from Fabricatis. What if the ugly elephant task that I made, which was a remix on that one here, perhaps this could actually be in several places. Translate by XYZ and then make a copy. Or just an idea that it could be... can I now rotate it? No, I can't.
I don't see Fabricatis on in chat, but Axel says that you should hide one of the bodies on that design. It is the STL body, the one with the triangulated surface.
That's that. I was looking like a lot of that makes a lot of sense.
Right click and hide the STL body.
I was just wondering what the design intent was there. Yeah, so if Fabricatis is here, I'm curious to see if there is more, and there is no comments as I see here. All right, let's check the next one. But okay, the idea I got from that is that, you know, my hugger who's hugging the steel plate, it can hug in multiple places. I think we get the best out of the front here, and it can actually hug without using more material than that. Sorry for not finishing that thought. We can make this I'm looking forward to soon making a much nicer version of this. I'm going to do that during the stream. I just want to look at all the designs first.
Yeah, you're eager.
I'm eager. It's so fun to see what people have done. I'm so happy for ideas. This is the first time, really. Axel was like pre-show, but this is the first time I'm collaborating on the Marble Machine 3 with the audience. It's fantastic, through CAD at least. So now we have, interesting.
Stroopwafel or something like that?
Yeah, but stroopwafel is a Dutch delicacy, which is the Dutch waffles. So this is probably a Dutch designer, and the Dutch, they're great engineers. Look, this is the same concept as who did that?
Jackum?
This one, yeah, Suminoma. This here. See this? And when two people separate from each other, think the same thing,
there's something there.
There's something there. That's why this is so fun to see other people's ideas. And if we check a thing here, I think this has a lot of simplicity. Look at these holes. They're simple.
Love it.
The holes are super simple, and but look here. Are they all? No. So these are not... Okay, so these are locating, and that's the only one that pushes forward. So you have to then make sure that if you push forward, that these really can go into their holes. It looks a little bit tight there, and that's why I think if we make this front, we take this idea, but we make it my springy idea. I think that is really, really good. So we don't make it solid, we make it springy-ish. And then here, there is a snap. And here's my next idea then, Hannes. I think we should make this springy too, so that it's really, so that you have to push it down so that it pulls. I want the profile to be pulled down towards the steel in both ends of the profile. So if we, for example, so let's remix this one, make a copy to add it. What stroopwafel?
Yeah. Your favorite dessert.
I brought stroopwafels to the studio because I know that if I eat one, I eat everything that is close to me. It's once you pop, you can't stop on the Dutch stroopwafels.
Okay.
So if we somehow can make both hooks flex downwards, we can add down pressure on both ends, which I think will be very, very important. So, like, yeah, I'm gonna butcher this as I always do.
What a man with confidence.
Imagine, like, this is not how you would design this, but imagine that this thing is a little bit cut loose so that it can flex. So I'm just going to remove this. Boom. I actually wanted to remove a little bit more. It's bad, but people in chat can think about how to make this nice. And we're going to... I want to do a remake in the stream, as I said. Bonk. My daughter laughs when I say bonk. I don't know.
Bonk. Okay, that's a new thing. Okay. Bonk.
Yeah, bonk.
It is funny.
It's not funny. That's
two out of 5 on the comedy scale.
All right. My arch enemy, the extrudes. Oh, this is bad, but because you need to press it down. But then this could be, and then this, we can move that face. I think everyone already knows where I'm talking about. We can move this face above the steel, so that when this is pressed down, this face will press against this face, pushing the entire profile down into the steel. So I'm going to write that down. It's here. I can close a few tabs later. Profile pushes up against underside of metal at both ends of profile.
Super snug.
Super snug. That's a super snug concept, Hannes. You just named it. The super snug. I think the super snug is fantastic. So people in chat can think about how do we do that in a really good way. I'm going to try to make my own remix about that later.
Yeah,
thank you so much.
We take more questions from chat later. Martin will keep on going through the suggestions here. Then we'll have some more time to talk and discuss with you in chat as well. So now we are on Duvi.
I haven't looked at Duvi's thing. Genius mind. Springs should have some pre-tension. See, it's this idea. Only use horizontal spring on the non-timing side for better accuracy. Vertical spring to pull the profile onto the drum. Ha! Same idea. You love to see it, but it's in a much better design also. So program profile Duvi. This makes me very, very happy. This tells me I'm barking down the correct tree, or what's the expression?
Barking up the right tree.
Barking up the right tree. Oh, it means there's a squirrel there. There's a squirrel in this programming profile tree.
Yes, it is.
So, okay, this was fantastic. My only complaint here is that I always look at the profile from the other direction. It's okay. Only use horizontal spring on the non-timing side for better accuracy. But I think the accuracy Duve could have added I think still on this we can add, which is an important concept. I think we can always add location pins that is not doing the work of holding it down.
Jimmy Thomas Dev is happy in chat. He's screaming right now. Yes, spring on leading edge only. Yes, he's so happy right now.
Why?
I don't know.
Only use horizontal spring on the non-timing side.
Spring on the back makes the register stress the spring less tight and more wear and tear.
Okay, so Jimmy, tell me why, because I don't understand why that would be. So, but you and Duve had the exact same idea, which means that there's probably something in there. But I don't understand why the spring would only be So I just added like location pins to this because Duve was worried about accuracy here, and I think like if you have location pins, I think it's a good design concept to have some things. These ones pull the elephant tusks, we can call them. Elephant tusk springs, pull the profile down hard, and these register the timing.
Chat seems to... It's because the profile will be dragged backwards. The pressure will be pushed backwards on the profile. So that is why it's better to have the springy part on the front instead of the back.
Okay, but then my timing tab solves all that. There should be no movement allowed in the end. Again, with the saving material holes here, Duve had the same idea.
That is nice.
That's really nice. I'm going to go to the text here. Soon I'll clean my tabs. There's too much flashing.
A glorious day.
Oh, you look forward to the cleaning.
Now people want super snug t-shirts now as well.
So add timing tabs that keeps the profile from moving and registers accurately.
I just want to say here then Derek Van Allen joined in as well here with a comment saying, because if you have a really short profile with only 2 pins, you want at least one hard one, and the hard stop would be better in the back.
So my idea for that, the only reason to make a really short profile is of course to save material. Okay, yeah.
A lot of people seems to be on the same, as we said earlier, a lot of people think the same thing. It's worth thinking about. So investigate springy on the front side and sturdy on the back.
Okay.
Could be something. Write it down.
You want me to write it down? Okay,
Yeah.
so
Only springy in the front.
people worry about moving. Keep the edge that is pushed, registering edge. Keep the registering edge that it's a good design that is pushed rigid. Yeah. Is what they want. But let me just show you why I'm not that worried. If I make a new sketch here, I think if we would have, like Derek says, a really short profile, that profile. So here's a really short profile. Boom, 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 boom. That profile would actually be printed together with the next profile. So like we never need, because when it goes down here, the profile is ended. We never need like a 2 centimeter profile. That would just be a difference in a longer profile. So see, this profile has 2 notes. And that is like something that I think a lot of people forget because they're still in the programming pin idea, that the top side here, where the profile ends, is completely free from where it registering to the programming wheel. So if we have, let's say we have holes, this is probably important for everyone. Let's make a circular pattern of this hole. I'm not going to make 64. We're going to make 16. Now we're going to make 64. And then we're going to pull this to the circle there. Boom. With the pins, we could only put a pin at that hole and at that hole. We were limited. With the profiles, I can end the profile wherever I want and then just put the feet back to these holes. So the top of the profile is completely independent to where the holes in the sheet metal is, which is a huge advantage. We can do this. That's the huge advantage of the profiles over the pins. So I think that's gonna be fine. Super cool. I don't really understand why everyone is so worried about that, but I'm not going to ignore it.
No, leave it in for now and we can research it more. And I'm just going to give you a tease here now, Martin. I also see a comment here from Ludwig saying, I've posted my idea now too. It's a very quick one and would probably only work if combined with all the other amazing ideas. So he did what you asked, and he sent an Onshape link for you to watch it later, Martin.
Fantastic. We're going to go into it really soon. Let's check the next one.
It's Andrew.
I think it's Andrew. Yes, Andrew Downing.
Perfect.
Programming wheel cams. Oh, with a lot of mate features. Interesting. Oh, with a lot of studio.
Ooh. Oh, what is happening here?
That's a lot of parts, but it's the same idea.
Look at the snake hook.
I thought there was a elephant tusk here somewhere, and I think it could be actually. That could be an. Oh, and this idea again. You see, the front is just there, going in. This is very beautiful. So, Andrew has made... Okay, this is interesting. I'm going to make a copy to look at it. Was it Andrew Downing? Andrew Downing. Boom, 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 boom. Thank you, Ludwig, for sending in the design. I was jokingly saying, because he came with an idea and knocked me on the shoulder, like, no, only taking suggestions through Onshape links. And now he was like, okay. Boom, 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 boom. This is very, very fun. Very, very happy to be in this part of the project. In some of the instances, I've been spending the entire week writing design requirements, having fun with it. While that's loading, I might be able to show you actually. I'm having issues with the dark reader on off site list. Ugh. So yeah, I've been cleaning up the design requirements a lot. So this is how the vibraphone looks now, and all this is completely gone through. So I made
deleted over 1,000 rows.
Yeah.
In that document.
I've noted for all the instruments. I noted what sounds they have, what playing techniques they have, what dynamic ranges they have, but what interfaces they have, what's interfacing with each instrument, and what each outgoing interfaces. Then I've written everything that is controlled automatically by the music program, manually by the operator during play, and manual settings by the operator between songs. So I've gone through all the 10 instruments and done a lot of thinking. So this is me slaying the design requirement monster, which will be a video that I think we will release tomorrow because we missed yesterday's Wednesday. And from here, I have to start cleaning them up. So one thing I want to do by the end of the stream is to go into the requirements for these profiles.
Mm-hmm.
Okay, let's see if there is any comments here. It's kind of obvious that the perpendicularity is being done by having another print like this, and thanks to the fact that it's close, the same print is helping a lot of tracks. And that's a really creative idea. I haven't thought of it, and I don't see anything wrong with it apart from a lot of parts. I don't really see how these are, if they are just snapping on. This would definitely work. There's more parts than one. Let's look through check. I love this. These are timing. These are the timing holes. So I think Andrew, I misspelled Andrew Downing here. You can't have that. Andrew. What Andrew have done here, which I really like, is exactly this idea. Let different tabs do different kind of jobs. These tabs do the timing, the task, and the front wedge is doing the holding, which I think is a really good design philosophy. So then we have the feet that does the... So again, letting each part do its own job. The feet does the perpendicularity. And the wheel segment, assembly standard, assembly stubby. Oh, that's the just shorter profiles. Perhaps a lot of people have designed with these shorter profiles in mind. Where I think then we rather combine it with the next profile. I think assembling, that's beautiful. This is how it clicks in.
Really, really thorough work here.
Very thorough. This feels kind of oversized, this long thing, but that also gives good flex. So thanks to the fact that this task is so long, the flex is just going to be much better and live much longer.
Task, I think you mean trunk, right?
What is task then?
Task is a bete.
Yeah, okay, that's the white thing.
Yeah.
The horny and pointy thing.
yes. I think it was like
swan.
Yeah. It's a swan snake, this one.
it's an elephant trunk blowing water shape. This
There
is
we go.
really beautiful. Thank you,
Okay.
Andrew, for sending this. We're going to get back to all this. I want to see. I want to see more. Oh, not here, not here, not here. We are in here. Okay, back to Andrew's idea. I think in my brain, adding another part for perpendicularity is valid, but it's an option I want to go to when I have exhausted the option that the first print can keep itself perpendicular on its own. I think it would be nice because it would be nice to not have to have these feet, is what I feel. Because as you see, it also looks a bit more busy. It's more elegant if it's without all these feet. Let's see if we can just hide them. No, it's the mates. Okay, I'm rusty here. Sorry. That's all the mates. Where's the parts? I'm in assembly. Okay, nothing. I would like a design without these feet, but this feet makes it absolutely certain that we can make it work. So that was cool to see.
So now we're moving over to Ben, right?
Ben Taylor. Same idea here with these rigid ones that just slide in. And then I would add to these. We have to talk about that later. Perhaps it's only the one in the front that can have the springy thing that I was talking about. What's this snap? This looks interesting.
The duck.
The duck snap. The clip profile.
How does it work?
So the clip sits. Does the clip read document?
Yeah. Ben Taylor says here, I left explanations in the document notes, left toolbar.
Hey, Ben, thank you for being here. This looks super cool. I'm going to make a copy to edits and see if I see read document there. Ben Taylor.
And then let's see, as Derek warned us about earlier, that the comments don't follow in a copy.
Exactly.
But you got the original there as well.
Yeah, the original is still there. I can go back to that if... Ben named a mate connector with instructions. That's pretty creative. Left toolbar, read document notes. Perhaps I need to be in the original then. It should be there. Okay, let's check the original. Here we go. Beautiful, Ben. One of the biggest challenges I see with the starting with the starting concept is printability. The concept splits it into two pieces: the profile and the profile and a clip. These are brilliant printing directions, obviously. The profile provides a cam surface to actuate the marble drops. It's flat, which opens up manufacturing process to. Yeah, we can also laser cut. It's the same. That's actually a good idea. So from Ben, I'm going to make my note earlier about. Here we go. Here, prog wheel. That's where we are. Multipart allows multiple print direction or multi materials, but also multipart allows multiple manufacturing machining options. 3D print plus laser, etc. which is a great point from Ben here. Here we go. Oh no, there we go. Open up manufacturing process. Great point. The hook tabs of the profile slide into the mount slots on the programming wheel and index against the front edge. Yeah, so that's where I would like to remix that. At least one of these could have the springy and press against the underside, or perhaps all of them. I haven't thought that through. Perhaps the middle ones can't, because then it would be hard to get it into the holes. The clip provides support for perpendicularity and a snapping lock to secure the profile in place. It could be 3D printed or with the volumes needed for 180 channels, injection molded. Yeah, that's really cool. Like, just make one of these and like ordered 100,000. What I like, Ben, with your idea is that you are bridging the gap from what I feel is a little bit suspicious home solution with the 3D printer to what I felt really comfortable with, like water cutting stainless steel. It feels like Ben's solution is like in the middle, where we can use other materials with plastics that hasn't been together in layers, with plastics that are truly fused together. So the 3D printed profiles, I'm a little bit like hesitant in some ways. Injection molded. It could also be redesigned to use a wire spring clip. Profile concept part studio models the profile and clip. Design intent features for explanations of key features. Where do I find that? This is interesting. I'm learning to design intent features. Okay, I have to find that. The clip flex part studio. Oh wait, it's in the profile concept part studio. So where is the design intent? Is it a sketch with design intent? Ben, if we're not on too much of a delay, how do I access the design intent?
It's only a 30-second delay, so.
Oh. Assembly notes, demo assembly, slide profile, push profile towards the lock, prep clip, deform clip locks in place. Beautiful. Really, really beautiful, Ben. If you can make a comment about the design, see the design intent features. Is that an Onshape thing? Or is it a comment? I don't have comments here. Yeah, if someone in chat can tell me if that design intent is actually an Onshape thing.
Design intent is the little light bulb feature. Ben Taylor says here.
Ah. Wait, you can add. I'm learning so much also. You add it to the tree. Now I have to go to my own copy here. Here's Ben's copy. What's this? It's
a custom feature.
Aha! So it's just a custom feature to
DI, design intent.
Design intent. Ah, cool. Onshape is so fun in that things. Like, okay, so let's go through Ben's wanted to like say set bounds of profile size, inner surface of curved base, design intent. Profile edge can be customized, get desired actuation shape. Is that then locked like a Onshape comment to something?
I also like that Ben says here, learn that from Evan Rees.
Okay.
Evan Rees out there inspiring people.
Influencing.
Influencing.
Yeah. Fit into slot. Evan Rees was absolutely fantastic in Evan stayed away when we did the stream from all the custom features because he knew it would be too much for my brain. Fit into slot and slide forward to mate. Okay, cool. Really cool, Ben. Learned a lot from you here. As I said, Ben has thought in the same lines as Julian did, that if we put a middle section, that does not have to be 3D printed. And then we can combine different parts, can do different jobs. I get stuck. My mouse gets stuck. And this could be watercut from some kind of whatever material, like POM or Delrin, super expensive, but really strong and absolutely. I like that idea. So 2D cut with laser water. The profile could use bushing material like Delrin, POM, expensive as I said, etc. Homogeneous plastic. It's that plastic won't. There's no layers, and it doesn't take time. We can order 5,000 of these. Of course, I couldn't then make myself, but we could then combine with 3D printed, and then combine with 3D printed clips or such. Boom, boom, boom.
Then Ben adds here in a comment. In the assembly, I have configurations to animate/manipulate each step.
Cool. Let me try those. Thank you, Ben. So configurations are not there. We are here. So demo assembly. Let's also then. Now we can look with the dark reader on. Okay. Oh, this is beautiful. Oh, wow. This is cool, Ben, because then you can use configurations as a kind of an animation, actually. So slide profile, push profile towards lock, prep clip, deform clip, clip locks in place. Nice. How did you do that? Okay, I'm not gonna learn that.
Not for now, but that's cool. A lot of cool features in here.
So yeah, Evan opened the surface for me with configurations, but this is how Ben has programmed it. Time for that zoom button, Hans. Clip slide. So yeah, this is a whole world for me. That's also so fun. I'm learning so much Onshape stuff. All right, I wanna see. Thank you, Ben, so much.
That was awesome.
Great designs. I wanna see what else we have.
We have Axel. Now Alex or Axel.
So this is the original Axel, I guess.
Alex on Onshape and Axel on Discord.
An entire wheel.
And Axel is still in chat, saying hi yet again here.
Nice.
Okay, here's something cool, a little bit different, right?
This is different. Hexagons are the bestagons, as everyone watching this stream knows. So that's very great. Like, I wouldn't have thought about that. What do we gain, though, from that? We gain perhaps better registering with the hexagons.
Even snugger? More rigid?
Yeah, perhaps. It's interesting. We don't have to stay with the with like a square hole shape. Perhaps no, printability is probably solved here. Just print it on the side. Okay, so this one uses hardware. Maybe that's optional. We could achieve the same press here with just a spring here. But same idea. This just goes in, and this really cool. Okay, so what do we get? Wait, what is this? Is this subunit? Is Axel here in chat? Now it would be great to have a voice
Axel
channel.
says here, I was trying to think through why I was having trouble with the existing design. I think custom bends on the sheets are a possible cause for error and tolerances.
So I see what you mean. But then this is another sheet that is straight here. Perforated sheet.
And then adds here, the ability for a manufacturer to bend a cylindrical form varies depending on the irregularity of the stiffness due to cutouts.
I see what you mean. The shapes. If we go to my thing here. Oh no, I need to reconnect. The shapes. The holes would make it bend unevenly. But my hope, it's a great question, Axel. My hope is that if the structure of the wheel is accurate, and if we make this curved base thin enough so it just conforms to the accurate structure of the wheel, it will flow like water on the surface. So it will conform accurately to the surface. Since I did these bending shapes on the Machine X, I never wanted to do them. That's why I made this whole grid solution with no stupid bending. Everything straight. But then I realized, like, the bending of a thin metal will be accurate enough, and it will be same around the entire wheel.
Axel says here as well, the straight sheet is a tool. I wrapped that onto the curved surface. Later I realized I could do it differently. Check assembly 3 at the end.
Oh, perfect. Thank you for your...
And there lies another issue. I think you should outsource that bending step. You can buy a prefabricated perforated aluminum sheet from 1 to 10 millimeters thick.
Yeah, I think the bending, Axel, as I see it, is that the wheel is going to... The metal is going to conform to the wheel. It's not going to be bent in itself. Thank you so much for the explanations. We are going to fix the voice channels for the next time we do this. Then
you find the assembly 3?
Then I could talk to you right off. I didn't, because there's assembly 2 here. And
at the end.
CAD imports, no. Home. Part Studio 3, perhaps you mean. Assembly 1, assembly 2.
Sorry, it's assembly 2.
Okay, assembly 2. Good.
Self-tapping fasteners. And assembly 2 goes with Part Studio 3.
Self-tapping fasteners. That's also creative, kind of. I'm worried about for in long term. This absolutely solves the perpendicularity surface. I'm worried about wear over time with this. But again, completely new idea here. So yeah, but I would be worried about wear of that one. And that is not really click out. Oh, I changed my mind and testing something, and the metal stays untouched. This is more like now we're really
set it and leave it.
This exactly. This is would be very sturdy though. Super cool. Thank you, Axel. Let's see. I want to go through everything, and then we're gonna come back from the beginning. Okay, Benny.
It's a comment, right?
Oh, and Paul has also sent this comment from Benny is a good one. I've read it because it was the only one who didn't send an Onshape link, and it has value from Benny here. But we're gonna save it for last. So Paul, and here goes Ludwig, the studio neighbor. Ludwig is an Onshape absolutely monster. Like he works so fast that I don't understand how it happens. Programming tab. I think he mentioned to me that this kind of plate is a thing that exists already. So I think like on Bauhaus and stuff, you can go and buy kind of these kind of plates.
Oh, it looks like a Mac screen.
Oh, it's exactly like the cheese grater. Actually, you're right. So I think, here it is, the whole plot. Ludwig, as the DIY guy he loves like to use things that is not intended to use for other things, and he's
I guess
absolutely.
you saw the link, right? He said sent a comment here now. There's a link to the product in the sketch.
Oh, fantastic. So and then so that's super cool, Ludwig. Thanks for sending. How is this? Oh, it's a little. How is this? Is there a little hardware here pin or? Oh, it's a set screw that clamps out, I guess. Super cool, Ludwig. Thank you so much for sending. I think like, oh, there's the link. Put the link straight into the sketch. Brilliant.
Okay.
Brilliant. Yeah, so what I don't like with this is that I don't get control over how many holes around the perimeter. I don't get control over the millimeter sideways. And so I think it's worth it making the custom plates because then we also need to do the fastening and stuff. But super creative, Ludwig. Absolutely love it. Let's see the time we're saving on buying something, we're losing back into conforming that thing onto the machine. That's kind of how I feel. Okay, so this is actually not an Onshape link. It looked like an Onshape link. No, it wasn't. It's just my eyes are only seeing Onshape links on this. So animations here. There's animations there. Thanks, Carl, for sending the allows infinite. What it allows infinite song length. Okay, we have to check this.
Yeah, we need to investigate infinite.
That's a huge claim. It still has a drum and pins that makes full revolution, so I feel it keeps with the. Each channel is made of two halves that can be easily CNC machined. One half rotates with the pins, contains slots for the pins to move. Okay, the pins. So we are limited to very few musical beats with this. It's not. The other half is fixed and has two. This would be a set and unset state. At one small section, piece missing that fall down, and they can be written to new state. So how super creative. Paul.
Oh, the worst. Electromagnet.
Okay, we go font 300. No, I'm joking. Super creative, Paul. Thank you so much. I think I don't see it misses one of the. Okay, so that's a perfect segue into the design requirements.
I just saw here now that Jimmy just sent a last minute suggestion. It's ugly, but it exists. I think he sent an Onshape link to me on Discord. So I will just fetch that and send it to you, Martin. So
Fantastic.
Jimmy gets to get his
fantastic.
Send his idea as well here.
So I think.
Give me a second.
One of the design requirements. Not Benny. What was the name of the? I'm in two documents. Okay. One of the design requirements is going to be the infinite resolution. So this is perfect. Like the programming the music program. I'm not going to talk about profiles. I'm going to say it's design agnostic. I don't have that activated. Okay. So the music program must offer infinite timing resolution, i.e. not be confined to quarter, eighths, or 16th notes. So this is the big difference where the profiles is so exciting for me, because the profiles takes an even grid of holes with 64 holes around perimeter of the wheel and offers us this infinite timing resolution where the where this drum is then set to 16th or whole notes. You see the blue pins here cannot slide half a millimeter forwards or backwards, whereas the programming profiles can. So that's one of the design requirements that this is not living up to. But very cool thing. So Paul, so thank you so much for sending it. Which
I sent you a link on WhatsApp, Martin.
Okay, cool. I'm going to open it.
I'm sending you random Onshape files now.
Yeah, I love where our relationship is going, actually. Thought you'd never ask. So let's temporarily show the beautiful machine that is standing over there.
There we have it. Look at that.
And the truth is, when I've been working with the design requirements this week, I've realized how fantastic it's going to be for collaborations. And I didn't give a lot of requirements. I just wanted ideas for the snapping, which I got. But we're going to. Oh, Jimmy has made a cool thing here.
Okay, can I switch over?
Yep. I switched here. This is Jimmy's last minute.
And just a clarification here. It's crude, but he also says here, to be clear, the slot idea in my suggestion is from TH Cyclist. I just saw he added a visual representation of it on #livestream visuals. So credit where credit is due.
So what is the slot doing and why is it there? Perhaps you can you go check, or Jimmy, can you explain what this slot is doing?
I can see if I can find it.
Is it a perpendicular thing? I like this design, Jimmy. It's I think for like a 3D printed profile, it's close to. That goes there. But I'm really curious of what this is. Is it something that you should stick in here for perpendicularity, or what could it be?
I just saw an image from the other. I can send that to you if you want to.
Yeah. I'll just have a sip of water. Giving me a lot of concepts that like I haven't crossed my mind, which is really, really good for me.
Yep. You got a WhatsApp from me from TH Cyclist, the slot idea. I tried adding in the document notes, not sure if they show, Jimmy said. Idea of the slot is to push up against the sheet to push it up.
Okay, I wonder if I can download it and save it to the audience, or just.
Yep, what Ludwig says. Yeah, I think that is that the part is straight. That part presses to the drum.
That presses to the drum, but it presses on the underside. Let's go to wide. I'm going to try to get this on screen somehow.
I believe in you. There we go. I see you got that fixed. Can I change?
Yep. So this is the visual representation, and the green is the metal sheet. But how that thing... I don't understand what it does. I don't want to miss the point here.
The sheet is curved. The printed part is not curved. Therefore, pressure be in the interference.
Oh, I understand. It's just going...
Axel.
Thank you, Axel. It's going... Okay, cool idea. That adds pressure on the other side instead. Okay, so in the real world, this blue thing wouldn't penetrate under the green line. It would sit on top. Just like when my thing went through the sheet and you got confused, Hannes, in the beginning.
Yep.
I got confused by the same thing here. This would stay over, but press down.
And then Jimmy says here, yes, that way it adds forces against the feet to keep the junction of the whole thing tighter.
Yeah,
it pushes it into position.
Yeah, it's super valid. It's I'm going to add it as a note here. So the super snug can actually be achieved in a way. Also, can super snug middle. It's not a good name, perhaps. The middle of the profile pushes down with something springy and creates the super snug hug. Super hug.
And Ludwig says here, I have a very good idea of show it to you, if it's okay to join you.
Yeah, come in.
Go, Ludwig, go, go, go.
Come in and make us happy. Ludwig is on vacation. He's dangerous when he's on vacation, actually.
Oh, yeah. Looking for stuff to procrastinate with.
So I mean, this is great. Oh, here he is. Should we go to we go to this one?
Yeah, there we have him.
Do you have a violin bow?
Violin bow, yes, I have a violin bow. It's hanging behind the sauce.
Of course it does.
I also have a round disc here.
I was thinking of showing it.
On the programming wheel, absolutely, you can show it. I can narrate because they won't hear you. So Ludwig is pressing the... Wait, we go to A7-3, perhaps.
This is good. Okay, focus it up and we're golden. Look. There we go.
I have to narrate because they won't hear you, Ludwig. Okay, so Ludwig is pressing the violin bow against, and we achieve pressure on the bottom of the wheel.
So the feet will automatically clamp.
Yep. And my idea, Ludwig, is to do it the other way around. The middle is rigid, and the feet pushes up on the underside of the metal.
Which will make it more flimsy with the small holes.
I think the cool come talk in the mic if you want to. Let's go back to a visual that Ludwig can comment on. Here, come close and.
Yeah. So I think that this idea, the other one with the spring on top, will make it easier because you don't have to have anything that springs upwards.
Which other one?
The ones that Joe, the developer.
Jimmy.
Jimmy, sorry.
Okay.
The one with the slit.
I know which one you mean. This one. This one. Yeah, this one.
Yeah, so I think this will make it a lot simpler to make the spring than having, because you will achieve the same thing where the feet will press up.
basically you think the spring can be designed better here instead of in the ends.
I mean, so I think that when you will transport this thing, everything is going to be shake a lot. So I think that the more tension that you have, the more secure each note is, the better. So I'm not saying that, but I do like having a spring that is simple instead of trying to make something on the feet themselves.
It's cool. I'm gonna make a version of this. I think.
All right. Bye.
Oh, bye.
Thank you, Ludwig.
Thank you, Ludwig. So I would like. I wanted to actually show this to Ludwig, but
I'll see it in the stream.
you see it in the stream. Okay, Ludwig. So I think I want to use everything. Yes. Dark Reader is my it's really my nemesis today. Dark Reader. I want to use all this. Okay, why can't I? Okay.
Ben Taylor says here, having the spring along the length of the profile means that the length of profile affects the spring force.
Yeah, I'm going kind of where Ben is thinking. I think it's that we can just add short springs like this on the top. It doesn't have to be like that. So just like we hug it by pressing down, up from the underside, we can also hug it by pressing down from the top side. So I think we can have much like shorter. The same idea, but another execution here. It could be, all this could be springs, pressing down. Which means that, just like Ludwig said, instead of needing to design the spring in the click things, the springiness can come from these things that folds up when we click the thing in. Which is actually opening up a new design space for me in my brain, which is great. I don't know if I prefer it, but I think we should start working on synthesizing all these ideas now. But to do that properly, I think I should start to write the design requirements. And I would love for chat to... and we're not going to write... I would love for chat to help me out here, because now we have a lot of really cool designs, but we have to have... look at me growing, everyone. Look at me growing.
Oh my goodness.
Here it comes. We have to have a measuring stick against which we can measure the ideas. Are they good or are they bad? I don't know. So what we're going to do now is the coordinate system in which we will find our way if a design is good or bad. And that coordinate system is design requirements.
Before you head into design requirements, Martin, I just want to say that now we have shown a lot of the epic and cool features of Onshape, and perhaps there's a lot of people out there that are like inspired to want to try out Onshape. And if they use this code that you see on the screen and that is in the description, you can try Onshape free. So head over to onshape.pro/Wintergatan. That helps us a lot as well. They see that you're watching these streams and that that our message get through. Yeah. Onshape is badass. Go check it out.
It's not a paid link. We don't get paid per at all. But it's they see if we get more people into the platform or not, and if we can continue collaborate. In that sense, it's helping us. They have been so nice. I'm so late on this. Like we talked a year ago, but the Onshape team here in Europe has been only fantastic to deal with. So I'm super happy to work with Onshape, and I it's, you know, some softwares you have when you just want to open them, it's like wearing your favorite sweater. That's how it is. I haven't actually been CADing a lot lately, so I haven't become a super good user yet, But I am.
But your fingers are itching, and that is a good sign.
And like Evan says, the ceiling is really high in the software, so I will be able to design the machine, and most of all use the collaborative feature as we have discussed and showed today. Okay, requirements. I kind of want to build them from the beginning, a little bit high level. Let's just see what we have in these old programming files. Programming wheel. The wheel must provide. The machine needs a music program. Okay, so here is a lot of requirements. I'm not going to build them from the top level now. Rather, I want to start talking about the exact requirements for these snap profiles that we're discussing. So we can start by saying, oh, we have one thing that I forgot from the document. It's Benny's written comment.
Oh yeah, the comment from Benny.
Yeah. So I think this is really worth reading through, even though I give Benny 1 minus point for not sending an Onshape link and a plus point for sending a great comment. So as we know, we need to do text wrapping when Sheets behaves like this. Where
if only it was as easy to use as Onshape, huh?
Exactly. Exactly. Good. Hannes, the hype is fantastic. Okay, everyone. So here's what I think is worth going through together, because I think a lot of you have this same idea. I'm just trying to not hide the text behind me and Hannes.
There we go.
Hey, Martin, please hear me out. You made a huge mistake in your design process. You correctly built this mock-up with instruments. Great job. Very important for planning. These instruments have a fixed size, so we know the size they take up, but the programming wheel does not. You just made up a diameter, and now this is stuck in your brain. The diameter of the programming wheel must be chosen wisely. The same is for the programming pins or sliders, however you call them. The size you currently have is just made up. First thing you need to do is to find the maximum length of one programming pin, then multiply this by the pins per rotation. I think this number is already fixed. This gives you the real diameter of the programming wheel. Maybe this wheel can be just 1 meter in diameter. You have been on such a good way to planning this machine, but this is currently a huge step back to the it has always been like that instead of following your design guidelines. I'm really sorry if I'm wrong and you already did this, but it seems like this size is just made up. Love this project. Best wishes to you and your family. Thank you so much, Benny. You're both right, and you're absolutely right in your philosophy. And this is where my communication sometimes lacks. I'm making a concept currently. We're pre-design requirements. You're absolutely right. The wheel does not need to be 160 centimeters in diameter. That's a size that I think is cool, and it fits one of our requirements, which is that the machine should look like a monster music box. We can take a look at it here. This turns the machine into a monster music box. But the machine also needs to go on a world tour and needs to be accurate and needs to be reliable. And that might call for a smaller programming wheel later. I'm absolutely not set on 1600 millimeter in diameter. It's something that I mocked up on the mockup. So I haven't made the decision, Benny. But you're absolutely right on calling me out for not making decisions willy-nilly. So I thought the comment was in really great spirit, and I really appreciate it, Benny. I'll take your feedback, but you also don't have to worry. The size of the programming wheel is not set. It might be only 1 meter, and we will find that out through the design process we are on. Sometimes I just can't communicate everything in the videos. Did that make sense, Hannes?
Oh yeah, absolutely.
Okay. So I think I want to synthesize all of these great ideas from everyone here now into design requirements and concepts. So this is where I think perhaps I should pair my requirements with a new CAD model that I make, so we can have something visual plus text. That would actually be kind of nice. let's pull this to here. And I want to see the design guidelines that I gave everyone. Here they are. So if chat has ideas of where to start this, I'm just gonna go on off the top of my head. This one is good. Snaps in and out from the top surface. No fastening from the underside of the curved base. Let's write this as a serious requirement. The profiles must, and then why do we know there's a profile? So we have a requirement higher up, and that was the. Did I write the thing about the timing somewhere? The music program must have infinite timing resolution, i.e. not be confined to a grid like 8th or 16th. Hannes, can you look up what IE means? Because it's like IE might not be a good design requirement.
That is, or in other words, it's an abbreviation for the Latin phrase id est, which means that is, or in other words.
That is, or in other words. Okay, so IE. Do I use a point? Oh, I have a good...
I.E, yes.
Yeah. I have a good dictation device, actually. I'm going to activate that. That I actually tweaked a little bit the other day. So this should be a little bit faster now. So testing the dictation and scratch that last part. See if it's going to do that. No, it didn't. Okay. So why I think profiles is a solution. It's not so if we want to stay design agnostic, the programming elements that's neither a pin nor a profile. And I'm not so annoyed anymore by being careful with words here. The programming elements must snap in and out from the top surface. Martin, the machine must offer... I should dictate this. The machine must offer the operator a way to manually program music on the fly on the machine itself. See if it's correct. Yeah, it corrected my language there. Nice. So let's pull this all the way up. So what I think then is important, let's just add a few rows. The programming elements must have a timing accuracy of plus minus 0.3 millimeters. I'm just making that up. But that from that requirement, we know that everyone was worried about the profile moving back and forth. That means, hence, it shouldn't move more than 0.3 millimeters. And then sideways. Oh wait, I think I included something like that in my here. That it must stay perpendicular. Height-wise position tolerance.
Boom, boom, boom. Is it okay for you if I just out to the toilet fast?
Yeah, of course. I'm flying with my design requirements on myself here.
Yeah. See you soon.
The programming elements must remain perpendicular to the programming wheel. Max wiggle at the top of profile 1 millimeter in each direction. Oh, it wrote it out like that. I'm soon going to start to CAD and do the requirements back and forth. So let's actually start the new design where I will incorporate all the best ideas, synthesize all the best ideas from all these designs. So we're going to reconnect here. Onshape, create. Let's go here. It's going to make a new design. It's so empty when Hannes is leaving. I can do it inside this document is better. So let's do it in here, new part studio. Create part studio. So this is going to be V3, I then guess. Here. Rename. Profile V3. Tick. And this is only going to capture all the concepts that we've talked about here. 1600, huge, in a great way. I hope. So I'm still, yeah, we have to talk about the printability and stuff a lot. Actually don't want that. There's also a chance of making them lower, depending on, it's a huge discussion. So all these are just concepts, but just to remind everyone that perhaps we can get away with really low profiles. That's going to put more force on all the things reading, more sliding force on the surface with less leverage. But it's a good idea. So let me add just the concepts here. We can have one concept that I think is absolutely brilliant is the front toe hook, which a lot of you incorporated in your designs, and I think that should absolutely be a thing. The front toe hook. So I'm just going to do them ugly, and then we'll get back to it. So like that. So I want to go.
Boom.
Boom. Nice. It's very empty when you're gone.
I'm back, baby. And also grab some fresh coffee.
Nice.
And I see here that Jimmy has sent a super chat. I don't know if you have solved this yet, but 1 millimeter at current estimations is 5 milliseconds.
Oh, cool, Jimmy. Thanks for the support and the great data. So that is then if we can get down to my crazy requirement of timing accuracy of plus 0.3 millimeters, we're like at a millisecond precision there. Very happy about that.
Boom.
Boom, boom, boom. So I'm going to do concepts here. So I think to answer this requirement that okay, so let's just say the programming elements need to stay snug and secure in their snapped in position. It's not a super impressive, but what I think a concept for a solution could be for that requirement could be some springy things. And then the new idea that Ludwig liked is that so here's the brainstorming around how we can design these springy things. So we can make the front toe hook springy, clamping the... I also realized the more springy we make everything, the more the programming profile wants to curve the metal in the other direction, which might be an issue actually. Clamping the sheet. All the spring features the spring features are going to want to straighten out the curved surface. The spring tension is going to counteract the bend, which is important to keep in mind. That's just a note for myself here.
And I'm just going to give you a note for your brain now, Martin, because we have approximately 1 more hour of this stream today.
Nice.
Yeah, so you can plan some stuff if you want to go more into Onshape or so you don't postpone that too much today. I don't know what you have planned.
I did it already, actually, when you were gone into Onshape. But that's a great reminder.
Yeah, also a reminder for me. I got butterflies in my stomach now. I need to focus on this.
Oh, is it because your video release?
Yeah, I'm releasing a video in 1 hour. I got reminded now when I saw the time. I was like, oh no. Too much pressure.
Can you paste the link in chat, Hannes?
I can paste the link when it's when it's released. Okay. 4:55. I can paste it. My big adventure video. I can paste it.
After the stream, everyone should go and look at Hannes' huge adventure video. I think it's going to be a banger.
Oh, cute.
The spring. So we can make the front toe hook springy, clamping the sheet. We can also put the springs in the middle of the profile, leaving the front and back hooks alone to do what they need to do. It's just I'm just writing down here my synthesizing of what everyone has said here. So here's the front toe hook. And then Ludwig loved the idea to add springs in the bottom here. Let's see how we can do that. If we break that line up into several lines. Do this to this. No. Is there no short key command for center point arc. So here's the spring idea, which I think is interesting in the middle of the profile. So something like this, which is an idea I wouldn't have gotten myself. I don't know why I'm leaning to put the spring stuff. Chat. I'm gonna give you 3 options. Oh, can we make a poll?
I think we can.
I'm gonna design the poll.
I should be able to. Yeah.
I'm gonna design the poll for you. I actually want to make a poll. I just want to show first, perhaps. There's like 3 places where we can clamp the sheet with all these profiles. It's like in the back, in the middle, and in the front. So if I go back to that would be super fun. So poll, where should we hug the sheet? Only in front toe, only in back toe, only in the middle, only front and back, everywhere. Those are your options.
Where should we hug the sheet? So there's a...
Where should the profile have springy stuff to hug the sheet? I'm not gonna say which one is my favorite.
Where should the profile... Oh, no.
Oh. I can send it to you on WhatsApp.
Where should the profile have the springy thingy? springy stuff to hug the sheet.
I'll send it to you. So you can paste it in there. So go back to CAD. Tick. So we can have it. So just so everyone, this is the front toe. Here is the back snap. And here is the middle spring. Whoops. That was huge.
Oh no, you can only have 4 alternatives, Martin.
Okay, yeah, but that's good.
Should we leave the everywhere out of it?
No.
No, okay.
Which
should I remove?
Only front and back. Only in... only leave the only on back toe.
Only on back toe we can delete.
Delete only on back toe.
Yeah.
And then it would be better only on front toe, only in the middle, front and back everywhere. So remove the word only from only front and back. That was bad written there. So I think we need some location stuff that is free from the clamping. Yeah, this is ugly, Martin. This is fantastically ugly. I should just use one of the good designs instead and remix on that one. Tick.
Okay, so you're gonna have this the only in front toe, only in the middle, front and back, and everywhere.
Yep.
Good to go.
So here's the 3 options, everyone, on screen here. And here's my remix of that middle spring there. I mean, the middle springs are maybe not so bad because it's separating the design. The front toe is doing the front toe stuff. The back thing is doing the back thing stuff. And then we have these springs in the middle. Yeah, it might not be bad at all. I was just feeling that the front toe would give such great... Yeah. I know which one I will vote for, though. I wonder if I can make a more... I actually want to make a better design here. I'm going to clean this up. This is embarrassing. Boom.
We have a guess which is in the lead right now with 8 votes.
Everywhere.
Only in the middle.
Only in the middle. That's interesting. I guess then the cool thing is that these features can be really, really small, actually. Okay, I'm going to see if I can do this seriously. So let me not try to rush this. Let me start over and actually do this properly. The only in the middle option will, I think, leave the front toe being very, very small and sturdy. So I'm gonna start now by designing the sheet here. Let's say the sheet is 1 millimeter thin. 1.5. 1.6, I think, perhaps is some kind of standard.
Ludwig here with a comment. Personally, I'd love to see some of these ideas made into prototypes so you can test them before deciding.
Yeah, it's a good idea.
Yeah, and people are happy about that comment in chat.
Yeah, I think that's where 3D printing excels. So let me actually make no, we're going to do that. We're absolutely going to do that. Let me pull an arc. So I'm going to make this toe thingy really, really short and sweet. I'm going to tangent this towards this. That didn't work. What's wrong here? Something went wrong here. It's
time to get your votes in here, people, for the poll before we close it. Just a friendly reminder.
Oh, wait. Didn't Evan taught me how to do perpendicular to a curve? Normal too. Wasn't that what he did?
Yeah.
Normal
right.
2, right? Because that's what I'm... So if I search for... I'll see a normal 2. No, this is not what I want to do. Normal Shift K. Wait. I want to Shift K U towards U. No. Then it made it tangent. I really want to make... Because now when I want this to point towards the center, I always like have to drag a help line from the center. I don't know if someone in chat... I kind of want to make this line perpendicular to a curve. And look, normal, it shows exactly that. If I choose both of them and press normal, no.
No.
Oh, wait, yeah, okay. It just fell out of the... Yes.
Aha.
It's normal too. That was Evan taught me. Nice.
There we go.
That will save some time. So what I want to do here, I'm going to add the fillets afterwards. I learned this from Derek, that I should sketch with simple lines. Are you closing the poll already?
Pretty soon.
Okay.
We can't have it going forever, you know. We have 23 votes that have come in so far.
Fantastic.
I see a clear winner already, but let's keep on going here.
So I think we could design this with very little material. How would I... Can make this toe really simple. Okay, sorry, Derek. I am going to make a curve here. I know it's... Let's make that tangential. Perhaps these should be equal. Okay, nice. And constrain the curve. Then it's for this. But did I make this also a curve? Yeah, I did.
2 more minutes, then I close the poll. Get voting, people.
Normal 2. There and there. Shift K, normal 2. Yeah, learned something today. That feels great. Normal 2.
Normal 2.
What? I don't need... Yeah, this is what I mean. We can make it so small. If this thing doesn't have to spring, we can... It can also be small. I don't think I'm going to... I don't know. But now I'm moving towards the result of the poll here. What I'm doing is the result of the poll. This doesn't have to be 5mm. It can be 4. Wow. What a difference, Martin.
Ooh.
What a difference. Dig. Just thinking about how we can make it really small.
Okay, I'm closing the poll.
Yep. Tell me.
with a whopping 56%. Only in the middle. Second place with 24% of the votes here. Only in front toe. 16% says everywhere. And 4% front and back.
Cool. Thank you, everyone.
What do we do with that information?
We pretend to care. And then we do whatever we like to do, honest. Now I'm actually,
wow.
I'm joking. I'm joking. If people in chat, I would love to hear. I think it makes sense. I don't know. The nice thing with not having it in the front toe is that the front toe can be really rigid. It can be very simple, the way I've designed it here. It can just be very, very super rigid. But I would love if people could motivate their answers in chat. It would be fun to hear that discussion.
Jimmy with a super chat and says here, I think we need to know register force to test.
Yeah. Let me see what scale I am in. Oh yeah, that was kind of what I thought. Boom. So let's say that it's there. How high is this profile going to be? Okay, it's 30 millimeters only then. That looks good. I don't know if I'm... The thing with making the springs here in the middle, I'm a little bit worried about this thin sheet metal getting pressed down in the middle of the profile. It feels like it will maintain its curve better if the spring is only in the front, but that's probably not true.
It's your fixed idea at the moment, at least, which will be difficult to know until it can be tested, right?
Yes. I'm still internalizing these.
Marinating them.
I'm marinating the. So if people wants to motivate, okay, the winners, only in the middle. Why?
Why only in the middle?
Why only in the middle? I'm curious. I should look a little bit about the things instead. Here we have the one from Thomas, the Fabricatis. Here's the straw waffle. I was thinking about going to Julian's. I want to check Julian's again here. Especially the later ones. So here, kind of imagine this one, but you bend the end here down a little bit. That would be like the middle. This design from Julian lends itself to the middle springs like kind of perfectly. These sections looks like middle springs. Yeah, it could be really that could be really nice. So if I take inspiration from Julian's thing here. Oh, check this out, Hannes. I think I have something. Wait. It's going to take me...
Just gonna see here now. I got some comment here. Henry F says, spring pushes down in the middle. Toes apply a reactive force on both sides. That's a good distribution of the point of actions.
Very good. Wait, can you send me that in WhatsApp, Hannes? I wanna put that into my notes. It's hard to copy paste it.
It's between the different computers, you know. I can screen grab it for you if that is that okay?
Yeah. Or is it on screen? I can read it into my dictation device. Hey.
Oh, there we go.
I just didn't see it. I like that motivation for the springs. Springs in middle are good because spring pushes down in the middle. Toes apply a reactive force on both sides. That's a good distribution of the point of actions. We're hugging the profile evenly across its entire length. Nice. Thank you for the comment. I think there is a cool design here. If we could... If my camel toe here, my toe, it's not that. The toe, front toe.
The front toe.
Is the official name here, Hannes. Boop. If that comes down like that, let's make this radius much steeper. Joof. Shoof. Let's make this 4 degrees. We can then have the spring, like in Julian's, come down like this, really close to this. So here's the spring, the middle spring, but it's really close to the toe here. Ooh, I like this. I like this a lot.
Ooh. He's cooking.
No, I think shift. Is it O for concentric? No, that's shift O. I was right from the beginning. Wait, I think this is beautiful. Beautiful.
Ludwig says here, if the spring doesn't bottom out, the reader might push it down and make it loose.
A good call. I see what you mean, Ludwig. Good call. But perhaps we can design them to that they have to bottom out to make it.
And people are agreeing with that comment, so
Yeah.
more people are thinking about it. No bottoming out equals less precision.
This went wrong. Bottoming out is interesting. So we can design it to exactly bottom out, but that feels like it's gonna be very Yeah, that made the whole thing a little bit more complicated all of a sudden. Shift O, you are also concentric. That didn't look good. Here's what I'm cooking. It's a spring.
It's a stew with a lot of different elephant toes and trunks in it.
That is really close to the trunks here. Trunk. I don't hate this. I kind of like this, Hannes. 3 millimeters. Yeah, it should be 3 millimeters. I think this should be 20. Boom. What happens here, Martin? Okay, so it's kind of hiding functionality inside, so we don't have to see it here. And it's good. I think it's good. I think it's good. I'm going to show you the top of the sheet here. You zoom in, it doesn't like. So this is how it is when it's like clamped into place, and this it's natural. I think also, of course, with 3D prints and stuff, they will lose their tension. We've seen that, like some of the plastic will super lose their tension. I think there should be springs like all over the place on this.
Kind of like Trevor says here, the spring should not be contacting at a single point. That will cause additional stress concentration. You want to distribute it like the violin bow example.
That's nice. So this curve, that curve should just go on the entire thing. That's a great comment. Let me just mirror this. Mirror my beautiful spring over the mirror line. What did I do?
Perfection.
I went out of the sketch. So let's do this. Let's say 3.4. I have no clue. Yeah, I don't hate this. This is just a ugly concept. This lacks functionality in the back thing here. To me, it kind of feels like the front toe should be springy. It feels like we're okay.
Are we circling back?
What was the second place in the poll, Hannes? Was that only the front?
Only in front, yes.
Yeah.
So only middle, only in front. The two big ones.
Cool ideas. Oh my. Perhaps constrain stuff, Martin. I wonder if I can do normal too on those. I'm just internalizing this thing. Because what I didn't like, what made me worried about Jimmy Thomas spring is that it was stuck at both ends here. So I really wanted it separated somehow. The idea that kicked it all off.
Interesting.
So yeah, that's one way.
Jimmy adds a comment here. Try to represent the forces that the registers will apply when thinking.
Yeah. They will add a lot of downwards force. It's a good comment, Jimmy, and that's why probably I haven't been too worried about it, because it feels like the registrators are going to push the programming pin profiles more firmly into where we want them to be. I feel the forces of the readers is not going to be an issue. So when we start to think about the timing pins and stuff, then I'm pivoting into the second thing of the pole, that it's actually the front thing that has the spring. Because then everything else can just follow the surface of the sheet, which means that we can add pressure evenly along the entire underside. So let's see what happens if I remove all these springs. Boom, 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 boom. Because now I want these timing pins in the middle of the. I really like the concept of not having the snap stuff registering the pin timing wise. So things can do their own stuff, is what I mean.
Mm-hmm.
So here instead, how is that going to be springy? It's going to be like this. Mm-mm.
And Ludwig here agree on Martin's current sketch. The foot is the wrong way for the pressure, correct? It will push it loose.
I didn't quite understand how.
Front hook should hook backwards.
Front. Okay, I don't understand.
You should turn the foot around.
Pointing
The
this
hook.
way.
Yeah, the hook.
But then we can't slide it in. We slide it in backwards. Yeah, we can slide it in backwards. Why? Ludwig, why? You're probably right, but why?
Because I'm guessing if it's pointing forwards, it will get loose with time, right? Make it much sturdier. Now Ludwig says, yes, you slide it in the same direction as the reader hits the profiles. And Jimmy says, yes, that's why foot is separate from spring on my suggestion.
Yeah, so the readers won't push the profiles at all. That's going to be impossible because of the... Okay, that's if we have... Okay, I understand the discussion. It's if we have a design requirements that says that the pins should be as short as possible.
The profiles.
Thank you for the clarification. I always added the registering things as well. But okay, the hook. Yeah, okay. The hook, then we get a perfect registering edge actually it's a good idea, Ludwig. It's a good idea. If we turn the foot around, we get more things out of one thing. Let me actually remove all this. I don't know why I can't draw. Sometimes during stream.
I know why. It's blood hour.
Sometimes during stream, Hannes,
you lose your all abilities.
I lose all my abilities. So I won't do a single more serious. I'm just going to draw the concepts with straight lines.
Mm-hmm.
So here's the profile now. This is much better actually. So if we then do the front hook backwards, So programming wheel turns this direction. I don't think the readers are coming and reading like so. And if the front hook is like this, but has a spring. So it sits with the body like that. Tick, 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 tick. Spring.
Yeah, chat is holding their breath now. Are you gonna use this suggestion?
Which suggestion?
Yeah, changing the foot.
They love the fact that it's
on the other way,
pushing up against that. It's not bad. It's not bad. It will then. I mean, we have a registering edge here, and with the use, it will always push up. So you can say that all the left side is going to be the registering edge. Yeah, okay. You won me over. I just didn't have time to internalize.
It's worthy of a golf clap.
This profile can... Okay. Can I do this? I love that I CAD like a 5-year-old in an Onshape supported stream. So good.
But you see, even a 5-year-old can use Onshape. It's perfect.
So good. Then I want my registering pins. But that's with the concept if there is no registering pins, I guess. So this could be... So this could mean that there is very few. Okay, this could mean that we can make some profiles really small and really, really simple, which is probably very important for when we have 1 million profiles. So then what happens on this side? Then the snap happens. Same there. The profile can end wherever. And in here we have a snap. No, that's bad, Martin. Okay, my brain is fried.
Cover your eyes, everyone.
I do know what I'm doing. The snap will just snap like this. Snap. I mean, we don't need a lot of overhang here. The snap can be at the very end. Actually, that's probably better. Boom, boom, boom. Oh, Martin.
You're gonna get there.
I'm worried about fatigue, like on these things. I think Julian had interesting. I mean, this
gonna be fun prototyping and testing this stuff.
This is probably the simplest concept. You push it in here, that has a spring to it, that is actually not present at this moment, which adds the upward pressure here under the sheet once this clicks in under the sheet here. And then you have this whole line is touching the curve, and then we can do... But I still think we need these things. Oh yeah, it's so warm. I'm fried actually, Hannes.
You're fried.
But it was.
Has there come in any late second suggestions?
Oh,
have you
that's a
taken
great
look
idea
at that? Who knows?
That's a great idea to look at that. Actually, I just wanted to look a little bit on all the beautiful suggestions. This is very much. I feel this one is really much in the vein of what we're trying to do. Let's check the.
Who knows if someone just threw something else in?
I don't see actually.
Okay,
but
there we go.
Good check. Good to check. I wanted to look at.
Yeah, you're fried, but you did great today. And what this stream really shown is the power of the collaboration in Onshape and how easy it is when you just get a link and you can open it straight in the software. And we saw it. You got a bunch of ideas and a lot of good feedback. It takes some time for you. You are a stubborn man. You will eventually come around to some of the ideas, I think. So to visually present the ideas this way is extremely powerful.
I think Ludwig is actually right. In this situation, printing out a fast little test print and snap it in is going to give a lot of feeling immediately for the situation. Looking at this, I really like the simple front toe here, but people think it should be the other way.
Andrew is in the chat right now. I made the one on screen now, but I should have put the spring on the front.
Okay, so that's interesting, Andrew, because it feels like your whole philosophy is super good here, Andrew. It feels like just when I see this, I'm like, but so why, Andrew, would you prefer the spring on the front instead?
Then he adds here, it works because there's a rigid register on the rear of the front foot, but it's not optimal.
Yeah, so what if, Andrew, what do you think about the idea of changing the direction here? So you actually fold, you point the toe backwards in here instead to have the perfect registering. That is probably a very solid idea. Because then we always have this edge. Yeah, it's a solid idea, I think. You put it in, you drag it back, and you click it down. And then you put your thumb here. Now the toe is pointing the other direction that everyone wants. You put your thumb here, you lift it up, and you push it forward. So it becomes, if I go into this cam, it becomes like a click back, remove forward. The other way is like in, down, chick, back, chick, out, chick, out. Yeah, it works. I think it works. Let me know more, Andrew. How would you feel, Andrew, if this point was on the other side of the front here? We would need the voice channels.
Then the spring would just push it away from that direction. Could that be?
Yeah, we would need the voice channels for that. This is not like rocket science, but it was like super fun to see the ideas. I think I need to go into... Sometimes I just can't think when I'm streaming.
Period. I just can't think.
I can take in during stream, but it's like I can't design during stream sometimes.
It's difficult
getting
getting a silent moment to think is also important.
I wanted to... go ahead.
I just wanted to once again the main focus on this stream was to take a look at the brilliant ideas from the audience and showcasing how easy it is using this software. And I think we did a very good job with that. It was super duper easy, right?
Absolutely super easy. I just feel... Yeah, I need to get back. I'm gonna get back to you all with with my synthesizing of all this, I wasn't able to pull my head together. I've been on a baby shower 20 minutes before the stream. That's my excuse. I drank alcohol-free Prosecco and it's getting to my head now.
Oh no! But I'm just gonna put this up yet again here. If someone got super interested in Onshape, you got a wonderful time to try it out here using the link. Use the link that is in the description or in chat. Don't try to type it in. That didn't work for me. So use the link that is in the description and in chat. And that helps us quite a bit because then Onshape sees that, wow, we have dedicated the viewers coming from Wintergatan. My goodness, we want to support them even more.
Yes. And so thank you so much, Hannes, for holding all of our hands. And I'm back on Julian's designs here. Let's see the number 4.
Yeah. Ooh, it's very pretty.
It's the what is always so fun is like that I have this idea in my head and people come with curveballs from completely new directions. And that is fantastic, I think.
Perfect. That's a good time to end the stream. Now we'll go and cry in a corner and be all nervous.
About the mountaineering video.
You can hold my hand.
Okay, but Hannes,
you know the struggles.
Let me promote your channel a bit then. Why not? Why not?
Okay, I'm humble now.
Why
I don't
not?
want anyone
Why
right
not?
now. I don't want anyone to see it right now.
Why not? I'm going to go get it. Hannes did you didn't do a videos for a long time, but then you did a big one now.
Yeah, since my dad died, I haven't done anything, and this was my big homage video to him. Basically, we talked about it in the hospital before he died that I wanted to do this adventure. So, what are you?
No, I didn't find it actually.
It's not online yet.
Okay, it's not online.
It's 5 more minutes.
It's the Trainer's YouTube channel. And it's going to be in the description of the stream, I guess, after we finish the stream. You can put it in the post chat, right?
I think so, yeah.
Yeah. Fantastic. Thank you all for your suggestions. They went straight into my brain and killed it. But this way of collaborating, as Hannes said, is really works for me. I just sometimes I'm a very introverted person. Like with design, I feel that's probably something that I need to like learn a bit more, Hannes. That I want input, but then I need to like withdraw to my chambers, and then I can kind of come back with something based on all the inputs. So that's what I'm going to do. Next time, we're going to have the synthesized suggestion, and I should, as Ludwig said, start to print it out and test it soon. Thank you everyone for sending fantastic designs. That's really helpful for the project. And thank you, Hannes, for being here with us. And Onshape for supporting the marble machine.
Absolutely. Thank you, Onshape. Now, let's celebrate by doing the thing I love to see more than anything in the whole world, and that is Martin running up the stairs and then victoriously just throwing his hands up in the air. All right, thank you all for joining in today. See you when we see you.